OSPF version 3 address family configuration and troubleshooting. In this video, I'm going to talk about the OSPFv3 address family, and I know that you have learned about this version of OSPF version 3 configuration, but here we are reviewing this topic, and after that we can talk about the troubleshooting tools, and so also we will experience trouble ticket related to the OSPF version 3 address family configuration. You know that in this type of configuration, we have the option of configuring OSPF version 3 for both IPv4 and also IPv6. I'm going to show you how we can configure OSPF version 3 address family for both IPv4 and also IPv6 address family. After that, we can review these commands for configuration, for verification, and after that we will experience trouble ticket for OSPF version 3 address family. Because of faster configuration, let me to use the notepad file. Here we have 3 routers. We can simply configure each router. Let me to show you enconf. Okay, we have interface serial 10 on the router 1. This is the serial 10. We should configure 2 IP address. First IPv4, second IPv6 IP address 10.1.2.1. Okay, let me to show you the labels of each interface here. As you can see, we have this label serial 10, serial 11. Okay, let me to show you interface serial 10, IP address 10.1.2.1, 255.255.255.0, and after that IPv6 address. Okay, then 2001 db8 12:1/64. That's it. And after that, no shutdown. If you want, you can configure the for example link local address, and also it is recommended. About the serial 11, we should configure interface serial 11. The IP address is 10.1.3.1, 255.255.255.0, IPv6 address 2001 db8 13:1/64, and also we have one loopback interface loopback 0. IP address is the for example quad 1 with the mask of quad 255, and after that IPv6 address 2001 1/128, and then no, we don't need no shutdown. That's it. This is the configuration of R1 about the IP addressing. Also about the OSPF configuration, first we should enable IPv6 unicast routing. This is the first command that we need. Then router OSPFv3 okay, means the OSPFv3 address family 1. Here we can configure address family, okay, IPv4 address family, IPv4, then for example unicast. Now we have this address family, and also you can configure different router IDs for each address family, or same router ID for both address family. Router ID, for example, quad 1. Okay, and after that address family, okay, IPv6, then unicast. Okay, let me to configure the router ID. Router IDs, for example, quad 1. If you want, you can configure different router IDs. And then after this configuration, over the interface serial 10, we are using OSPF, for example, OSPFv3 for IPv4 and for IPv6. OSPFv3 IPv4, then area. Okay, first OSPFv3 1 process ID, IPv4, then area, then for example quad 0. Okay, after that OSPFv3 1 IPv6 area quad 0. This is the configuration of the serial 10. As you can see, it is so simple. Then for the interface serial 11, we are doing the same commands. OSPFv3 1 IPv6 area quad 0, OSPFv3 1 IPv6 for quad 0, and IPv4. Then about the loopback 0, this is the interface loopback 0, OSPFv3 1 IPv4 area quad 0, OSPFv3 1 IPv6 area quad 0. This is the configuration of the for example router 1. Now let me to configure the router 2. We can copy the configuration of router 1. This is the R1 configuration. Okay, and after that we should modify this configuration for the router 2. This is R2. Here in the router 2 we have interface serial 10. The IP address of this interface is 10.122.255.255.255.0. Then IPv6 address 2001 db8 12:2/64, and then no shutdown. Let me to remove the interface serial 10. Interface loopback 0. Okay, and so we have removed the interface serial 11. Interface loopback 0. IP address is quad 255. Then IPv6 address 2001:2/128. IPv6 unicast routing, router OSPFv3 address family IPv4 unicast, router IDs quad 2, address family IPv6 unicast, router IDs quad 2, and then OS interface serial 10, OSPF1 IPv4 area quad 0, and then OSPFv3 IPv6 area again quad 0. We don't have any interface serial 11, but we have interface loopback 0 with the similar command OSPFv3 IPv4 area quad 0, OSPFv3 IPv6 area quad 0. Now let me to configure the router 3 also. This is the R2 configuration. Let me to copy it. And this is the R3 configuration. Okay, interface serial 10, IP address is 10.133. Okay, 255.255.255.0, IPv6 address 2001 DB813:3/64, and then no shutdown. Also we have interface loopback 0, IP address of this interface is quad 3 quad 255, IPv6 address 2001:3/128. Then IPv6 unicast routing, router OSPFv3 address family IPv4 unicast, router IDs for example quad 3. Okay, and then address family IPv6 unicast, router ID again quad 3, interface serial 10, OSPFv3 IPv4 area quad 0, OSPFv3 IPv6 area quad 0, and finally interface loopback 0, OSPFv3 IPv4 area quad 0, and OSPFv3 IPv6 area quad 0. Okay, let me to copy the configuration of R3 and then paste it on the R3 configuration. This is the R3 CLI. As you can see, now we don't have any error message. Let me to copy the configuration of the router 2. This is the R2 configuration, and let me to paste it on the router 2. And after that, finally the router 1. This is the R1 configuration. Now we can verify our configuration with the different show commands that we have. Starting with the show IPv6 protocols. Look at here. The first command is show IPv6 protocol. The second, show OSPFv3 interface. Third, show OSPFv3 for example neighbors, and then show OSPFv3 database. It is so easy. Let me to show you the result of this configuration. Okay, here in the router 1, starting from router 1, show IPv6 protocols. Look at here. IPv6 routing protocol is OSPF1. Router ID is quad 1. Number of areas 1 normal, 0 stop, 0 NSSA. Interfaces on area quad 0 includes loopback 0, serial 10, and serial 11, and then we don't have redistribution. Actually, all of our result in the show IPv6 protocol equal to the show IPv6 protocol of the OSPF classic configuration, OSPFv3 classic configuration. Also in the router 2, we have similar configuration, show IPv6 protocols, and also in the router 3, this is the router 3 configuration, show IPv6 protocols. That's it. After that, we can use show OSPFv3, okay, interfaces, and then interface them. Here, if you don't use IPv6 or IPv4, it shows you both address family of IPv4 and also address family of IPv6. But you can use the term IPv4 or IPv6 to see only the result of IPv6 interface or IPv4 interfaces. Look at here in the router 1, I'm going to use show OSPFv3 neighbors. Okay, show OSPFv3 neighbor without IPv6 or IPv4. Here we have two neighborship table. First, OSPFv3 address family IPv4 with the router ID of quad 1, OSPFv3 address family IPv6 with the router ID of again quad 1. As you can see, the result of our two show command exactly are same. Okay, after that, if you want, you can use show OSPFv3 for address family of IPv6 then neighbor, or IPv4, okay, then for example neighbor. That's it. Also in the router 1, we have neighborship between the router 1 and router 2 and router 3 for both address family of IPv4 and IPv6. In the router 2, show OSPFv3 neighbor. Look at here, we have neighborship in both address family of IPv4 and also address family of IPv6. And then in the router 3, show OSPFv3 IPv6 neighbor and also IPv4 for example neighbor. Also show OSPFv3 IPv4, show OSPFv3 interfaces brief. Look at here. Here you can see two address family beside of each other. First, interface loopback 0 is residing in the process 1, area quad 0, address family is IPv4, the cost is 1, and also serial 10 we have the similar information. Here, as you can see, we have two address families in this show command, but you can use show OSPFv3 IPv4 interface brief and also IPv6 interface brief. Both of them are similar, but here you can see we have a field, we call it a address family or AF. In the router one also, show OSPFv3 IPv4 interface brief, and then IP, for example, v6 interface brief, and then without IPv4 and IPv6. Look at here, all of or for example result are available here. Because of that, we can use the term IPv4 and IPv6 before neighbors or before the interfaces. IPv4, IPv6. Also about the database, we have the similar condition, IPv4 database, IPv6 database. Let me to show you here in the router one, show OSPFv3 IPv4 database. And here this is the result, exactly the same result that we have in the IPv6 database. Look at here, this is IPv6 database, same result. Also, only we have here one difference, and as you know, when we are using OSPFv3, okay, for both address family of IPv4 and IPv6, the OSPFv3 should send both addresses of IPv4 and also IPv6, you know it. And because we have two databases, LSTB of IPv4 and LSTB of the, for example, IPv6. After that, we should use the show IPv6 route OSPF for the information received from the, for example, OSPFv3, or you can use show IP route OSPFv3. Means the IPv4 route we have learned from the OSPF version 3, okay? Look at here in the router one, show IP route OSPFv2. If you use show IP route OSPF, the result is empty. Why? Because we didn't enable the OSPFv2. You should use show IP route OSPFv3. As you can see now, we have two line of information. Also, we can use show IPv6 route OSPF. Look at here, the OSPF learn route. Now we have connectivity to the quad 2. Okay, with the source of loopback 0, and also we have connectivity to the quad 3 with the source of loopback 0 in IPv4 and also in IPv6. Ping 2001 :2 with the source of loopback, for example 0, or ping 2001 :2. It's okay, and also :3 if you want. You can send traffic with the source of each interface that you want, or IP address you want, 2001 :1, okay, or ping 2001 :3 with the source of 2001 :1. That's it. Now, as you can see, we don't have any problem related to the configuration and also verification of the OSPF version 3 address family configuration here. Because we are using the address family term for configuration, we call it address family or OSPF address family mode. But in the classic mode, we are using IPv6 router OSPF, then process ID, and we don't have any address family under the router OSPF process. I know that you have learned about these features previously in this course, but in this video we have reviewed all of the, for example, functions of the configuration and also some of the show commands. Also, assume that you want to configure one area as the stop, include IPv4 or IPv6 address family. You can use area ID stop. If you want to configure one ABR as the total, as totally stop ABR, you can configure area ID stop, no summary. If you want to advertise default route, you can use default information originate under the address family IPv4 or under the address family IPv6. Everything is same with the OSPF version 2. Now, let me to show you one trouble ticket related to the OSPF version 3 address family, and after that we can better understand the structured troubleshooting related to the OSPF version 3 address family configuration. This is our scenario for troubleshooting of the OSPF version 3 address family. Here we have a problem. Users in branch have indicated that they are not able to access any IPv6 enabled resources on the internet, but they can access IPv4 enabled resources. What does it mean? It means that from this branch, okay, we don't have connectivity to the internet for IPv6, but we have connectivity to the internet of IPv4. This means that, for example, from this branch, we have connectivity to 192.0.2.1, but we don't have connectivity to the 2001 db8 :f::f. Let me to show you first. Starting from the branch router, let me to use ping command. In the branch, ping IPv4 first, ping, extended ping, then protocol is IP, target IP 192.0.2.1, the internet, for example, and then repeat count is 5, datagram 100 byte, timeout 2 seconds. We need extended commands, and the source interface should be 10.4.0.4, the IP address of the ETH01 of the branch router. That's it. Let me to show you the result. As you can see, we have a connectivity to the IPv4 internet. After that, ping, then protocol is IPv6, and then target IPv6 address is 2001 db8 ::f, for example, okay, and repeat count is 5, datagram is okay, timeout is okay, extended command yes, source interface 2001 db8, okay, 0.4:4, that's it. Okay, let me to verify the result. As you can see, we don't have connectivity. Okay, why? We should find the reason. First, let me to show you the routing table of branch router. Show IPv6 route. You can use this command. Okay, in the routing table of branch router, we have default route. Okay, and also if you want, you can use show IPv6 route for one IP address inside the internet, 2001 db8 ::f. As you can see, we have default route. Actually, in the router 4 we have pass, and the next stop of this default route is the one link local address. Okay, this is the link local address of the router 1. Let me to verify it. Show CDP neighbors. Okay, for example, detail. Here we have the information about the next hop is the WAN router. Okay, also if you want, you can verify the R1 show IPv6 interface brief. Look at here, this is the IP address of the ETH02, the link local of ETH02 4020. Okay, 4020, it's okay. On the branch router, as you can see, we have exactly the same IPv6 address. Because of that, we are receiving the default route from the router 1. It is okay. Okay, after that, let me to use one traceroute command. Maybe it's useful. From the branch router, I'm going to find where the problem is existing. Traceroute to the 2001 db8, okay, ::f with the source of, you can use source, but let me to use this command, numeric, for example. Okay, that's it. Look at here, trace to 2001 db8 ::f. We know that we have a pass to the router 1, and we expect that this traffic can reach to the, for example, gateway of the network router 2, and after that to the internet. But we can verify the result. We have received one default from the router 1. As you can see, traffic is receiving to the router 1 2001 db8 ::1. After that, the traffic cannot pass to the, for example, the next router here. This means that we have a problem. Let me to verify the R1 routing table. Show IPv6 route for the 2001 db8 ::f. Look at here. As you can see, we don't have any pass. This is our problem. As you can see, in the router 1, okay, we don't have pass to the 2001 db8 ::f. Means here we have a problem. Okay, you know that in branch router we had a default route, and this default route in the branch router, show IPv6 route, okay, is a default route that we are learning it from the LSA type 3. Okay, why? Because the code of this default route is OI. Look at here, show OSPFv3 IPv6. It can show us that the area 1 in the branch router is a stub area, actually, because we have configured a stub area on the branch router and also on the router 1. For area 1, we are receiving one LSA type 1. Okay, let me LSA type 3 include the default route. In the R1, also let me to show you the show OSPFv3 for IPv6. Here, as you can see, about the area 1, we have this term. It is a stub area with no summary, let's say, in this area. This means that here, area 1 is a totally a stub area, not a stub area. Okay, until now we don't have any problem. Let me to write here. Here we have totally stubby area. That's it, okay? And we are receiving default, but the R1 itself doesn't have default. Because of that, when the traffic is receiving to the, for example, router 1 cannot forward this traffic to the, for example, R2. You know that router 1 is residing on the area 0, and area 0 cannot be configured as the stop area, okay? We need to have default information originate on the router 2 for address family IPv6, okay? Let me to verify the status of router 2's configuration. In the router 2, we have this command show run, okay, section IPv6 root OSPF, okay, section router OSPFv3. Let me to show you router OSPFv3. Here we have this configuration on the router 2, router OSPFv3 1, router ID is quad 2, and then address family IPv4 unicast, default information originate always in the address family IPv4, but we don't have this command on the address family IPv6 unicast. Look at here. Also, we have area 2 as the stub area. Because of that, in area 2 we don't have problem. Why? Because this area is a stub area. Now R3 has a default route. Let me to show you. Show IPv6 route OSPF. We have default route received from the router 2. We are sending traffic to router 2, and router 2 has directly connected to the internet. Okay, we don't need to, for example, receiving any default route for IPv6, because with the stub area configuration, actually we are receiving default from the router 2. Let me to show you from the router 3. If you use ping command, you can use ping, then IPv6 internet 2001 db8f:f, and after that we can use this source IP 2001 db8 for example 03:3. We will not have problem. Look at here, we don't have any problem. But because here the R1 doesn't have defaulted, it cannot send traffic to the router 2. Because of that, in router 2, in the address family IPv6 unicast, we should add the defaulted router OSPF process v3, okay, 1 on the address family IPv6 unicast. We are adding this command default information originate always, because on the router 2 we have connected directly to the internet. This is emulator, this is not real internet. Here we have a computer with 2 IP address. Because of that, here actually on the router 2 we don't have default. Because of that, we should use always. That's it. Now in the R1 we expect to see default route show IPv6 route OSPF. As you can see, we have a default route OE2. Why? Because we are receiving this default route, okay, from the LSA type 5. We are learning this default from the LSA type 5, and also in the show IPv6 route 2001 db8f:f. As you can see, this route can match with the default route that now we have. After that, from the branch router, now we can send traffic to the internet. Ping 2001. Let me to show you. Ping 2001 db8f:f. And then, for example, if you want, you can use ping, then IPv6, then 2001 db8f:f. After that, repeat count, datagram size, timeout, extended command yes. Source IP is 2001 db804:4. This is the IP address of the ETH01 of the router branch router. As you can see, we have connectivity. This means that the problem related to the missing of default information originate on the address family IPv6 unicast. In this video, we have learned about the OSPF version 3 address family configuration, and also monitoring command, and finally trouble tickets. Actually, until now, we have learned many things about the OSPF version 2 and OSPF version 3, from configuration, from verification, and to troubleshooting. Now it's your turn. You need to review all of the contents and concepts and configuration of the OSPFv3, and finally, after reviewing the OSPFv3, you can compare OSPFv3 and OSPF version 2, okay, v3 and v2, both of them, and now you need to gather all of your information in one package. After that, you will be master about the OSPF, because in the NRC course, actually, we are learning maybe more than 90% about the OSPF v2 and also OSPF v3. Because of that, everyone that has this knowledge I can ensure that it can pass all of the exams related to the OSPF, and also it can maintain the, for example, large networks include with the OSPF routing protocol in version 2, in version 3, and also it can use its knowledge, okay, or this knowledge for the future courses. For example, in many higher courses, we need the knowledge of the OSPF, and also in version of 2 and also in the version of 3.